Hello there Gas Appers, I'm Stuart from Ozo Hot Water. This is our first time on the Gas App Live Lounge and I'll be introducing Ozo Hot Water to you, showing you our range of stainless steel unvented cylinders, what marks them out from the competition and hopefully answering any questions that you might have. Now water obviously is vital to us all, but a plentiful supply of hot water is crucial to modern day living. Now we as a cylinder manufacturer know that combis are a thing. But if you've got a large property, or your customer has got a large property with multiple showers and multiple baths, the flow rate from a combi will just not cut it. Now the news, literally from today, is that the government policy, as we expected, will be pushing more properties away from gas and into electric heating and into renewables. And in those situations, you're just going to have a hot water cylinder in your house. Every house at some point in the future, I believe, will go back to having a hot water storage cylinder. Now, Ozo Hot Water are specialists in heating, managing, boosting and supplying hot water. We don't dilute our time by doing anything else. We don't make gas boilers, we don't make heat pumps, we don't make external controls, any of those things. We are quite dedicated to perfecting hot water storage. Ozo is a Norwegian manufacturer. We've been making cylinders since 1932 and we've been using stainless steel as a source material since 1970. Now this might surprise you, but we are actually the largest manufacturer of stainless steel hot water cylinders in the world. That really is true. We have a global business which is based on innovation and quality, and we are a substantial supplier into the UK market. What is it that marks us out? Well, quality is a very difficult thing to define. There's lots of things that you can talk about, but our strength is in the precision and the very tight tolerances of our almost completely automated factory near Oslo. And this has persuaded some of the world's largest and most prestigious boiler and heat pump manufacturers to ask us to make them cylinders and put their names on it. So what you, I hope, are mainly interested in is the products that we make and that we brand in the UK. Now the Super Series is our primary offer. It's our best-selling cylinder and it's also, we believe, the most innovative, revolutionary, unique cylinder available in the UK. Now we all know what a hot water cylinder looks like. Cold water in at the bottom, hot water out at the top, primary flow and return connections on the side of the cylinder. They're almost all like that. The Super S isn't anything like that. Not at all. Now here it is. It has a lid which you can just lift off and you can see that all of the connections on the cylinder are on the top. Expansion vessels, multifunction valve. This is what it looks like when it comes out of the box. Everything that you can see here is factory fitted. This is an electrically heated unit, or the Ozo Super Express or SX as we call it. This is a multifunction valve with a line strainer here, a pressure reducing valve which is set at 3 bar here, a balanced cold water draw-off point which takes cold water at balanced pressures for showers out of that point. There's a blending valve, a mixing valve in here which I'll talk about a little bit later on. Your hot water draw-off comes away from here, and on the safety side we've got an expansion relief valve which is here, which is set at 8 bar, and a temperature and pressure relief valve which is set at 10 bar. And as you can see, all of the pipes actually go out the back of the cylinder. Now the expansion relief valve at 8 bar, what's the significance of that? Well, basically it shows the level of strength and the level of robustness in the cylinder. The stainless steel that we use is 1.3 millimeters thick. That's quite a lot. There are many manufacturers who use a much thinner gauge of stainless steel, which basically means that the cylinders don't have the same tensile strength as ours. And if you've got a cylinder which has a much lower expansion relief valve setting, and what that does is it sets the maximum working pressure of the cylinder. If the valve setting is 3, 4, 5 bar, you can be pretty sure that the grade of stainless steel and the thickness of the stainless steel is much lower than what we have at 1.3 millimeters. The cold water is delivered from the cylinder into the cylinder via a dip pipe here. Now this is the multifunction valve which is taken off. There's a dip pipe which is attached to this, which takes the cold water right down to the bottom of the cylinder. The purpose of that is that by placing the cold water right in the bottom, you minimise the amount of mixing that takes place of cold water entering into the cylinder where the water is already hot. And by that method, you get the maximum amount of usable hot water out of the cylinder. Now you can see that we have twin expansion vessels that are nestled inside of this moulded lid. Now these are factory fitted and factory connected via this brass manifold and then a flexible hose into the multifunction valve. Now these vessels offer the space saving of a bubble top cylinder, but they have the reliability of a cylinder with obviously these separate expansion vessels. You don't have the worry of losing the air gap that you will have with a bubble top cylinder. Now because you don't need the large expansion vessel, you don't need to go searching for a fixing point on the wall, and we all know that that can sometimes be a problem because a full expansion vessel, as you know, can really be quite heavy. Now we don't do absolutely everything for you. As you can see, all of this is factory fitted, but we have a bag of bits here which includes a pre-shaped Y hose, and I'll just show you how this goes on. This is a pre-shaped Y hose that attaches on to the expansion relief valve and the temperature and pressure relief valve, and then that moves on to the 90-degree tun dish that you can see on the left-hand side. Now I'm not a plumber, so I'm not going to try and embarrass myself by fitting this up in front of you. So in true Blue Peter fashion, here is one I made earlier. Now this is the super coil, which is an indirect cylinder, the Ozo SC. As you can see, all of the pipes go out of the back. I'll move this forward. Again, you've got the full multifunction valve here. The main difference between the SX, the direct unit, and the SC, the indirect cylinder, is the provision of the primary coil flow and return connections on the top of the cylinder. So again, everything is on the top of the unit. These elbows are factory fitted. We have a standard elbow here for the return. On the flow side, we have a unique elbow basically, which actually contains a fixing port for an AAV. Now that is actually quite a new thing for this particular cylinder. We identified that the top of the cylinder was probably always going to be about the highest point on a central heating system, and so it's a fairly obvious place to put a fixing point for an AAV. That was factory fitted quite recently. We supply a Honeywell motorized valve here, which is turned over on its side. And by turning it over, it means that the lid on the cylinder can really fit on top of it without there being any snagging of this. Now all of the pipes, as I say, they all go out the back. They can then go up or down according to the installation. Because the pipes go out the back, you therefore lose the usual clutter that you've got with a hot water cylinder. You need less space. You can use a narrower cylinder cupboard, and 650 millimeters wall to wall, left to right. That's the width, which is the limit that you've got with a Super Series cylinder. Now the most important thing about this installation is to get the first fix right. We supply a template. Here it is on the screen with every cylinder, so that if you wish to do so, you can put the template on the wall with measurements shown about how high off the floor the connecting pipe should be for each capacity of cylinder. And by the way, there's 6 sizes from 120 up to 300 litres. The centre point is shown to show minimum distances from the left and the right walls, and the connecting points for all of the pipes, including the length of the tail that you need to leave the tails to marry up perfectly to the cylinder when you move it into position. Now we've seen that the primary heating pipes are at the top. We supply the elbow for the product, for the return side, and as I say, the unique factory fitted elbow with the AAV that contains a port for that purpose. Now there is a cutaway image which will be coming up on the screen. The cutaway shows how the coil is fitted inside the cylinder. It's hung from the top. The flow pipe goes straight down to the bottom, and then it loops all the way back up. The coil is mainly in the bottom of the cylinder with supports to prevent it moving. The majority of the coil is right in the bottom of the cylinder so that the maximum amount of usable hot water is created, and it then loops around and upwards. The bulk of the coil being in the lower end of the cylinder, it then returns to the top. The connections on the top are marked flow and return. I would generally recommend that you follow that direction of flow, because then you're going to maximise the amount of usable hot water that you can get from the cylinder. However, if you have a retrofit installation where the pipe configuration is just not going to allow that, it is possible to reverse the flow and return. You will have to change around the polarity of the motorised valve, but the cylinder will still work. Now, as you can see, the front of the cylinder, with the expansion vessels facing you, all the pipes, as I say, they go out the back. The cylinder, as you saw earlier, is supplied with a lid, which makes the installation neater, tidier, it's away from prying hands, and it actually reduces heat loss as well, because it acts as an additional level of insulation for the top connections. When the lid goes on, it means that the valves, the vessels, the pipes are all concealed and invisible. The Honeywell valve is factory fitted on its side so that the cylinder lid will fit on top of it. So you can see here that once the lid goes on, it's a really neat cylinder. Now compare that to a standard cylinder with pipes absolutely everywhere and usually a large expansion vessel on the wall. It frees up a dramatic amount of space in the cylinder cupboard, so much so that a popular option, especially in small properties, is that the cylinder can be placed on a washing machine frame and move the washing machine out of the kitchen into the cylinder cupboard. Now the Ozo Super S, with its space-saving features, can be fitted on top of a washing machine up to 210 litres. Competitor units will struggle with more than 150 litres in that situation. Ozo actually supply washing machine frames, and the one that you can see is the one that we manufacture. However, sometimes builders can make their own washing machine frames to suit a particular cupboard of a particular size, and the one that you can see on screen now is exactly that. In keeping with the hidden pipes, the electric connections are invisible too. The cylinder is built with channels running through the base on both sides, from the rear 3/4 of the cylinder down here through to the front and the electrical boxes. Now the electrical flex will pass through these channels and then up into the electrical boxes. This is the cylinder does not come pre-wired, but this has been shown for you. So this is a direct cylinder, an electrically heated cylinder with twin immersion heaters at lower and higher level. The cables come through the base of the cylinder, and they then go through conduits inside the cylinder through the insulation, and what that does is it keeps the cables outside of any prying hands and concealed within the confines of the cylinder. It is a much neater installation than anything else which is available. Full instructions are on the installation manual. Now, seeing as I'm talking about the direct unit, this offers even further advantages, and this has proved very popular in modern new build. These cylinders very often go in high-rise residential buildings. The immersion heaters and the thermostats on the direct cylinder are set to 70 degrees Celsius. Now you know that cylinders are normally set to 60, and you'll remember earlier that I said that there is a blending valve in the hot water cylinder, and this actually brings the temperature down and regulates the temperature inside the cylinder, regulates the temperature of the water exiting the cylinder to 60 degrees. Now having a blending valve at 70 degrees, it means, having the thermostats at 70 degrees, and the blending valve at 60 degrees means that we ensure that the water is safe from a scalding point of view, but uniquely to Ozo, there is more energy stored inside the cylinder than in any other cylinder of the same capacity. Now this extra energy means that the SX will deliver more hot water than any other cylinder. This is documented in what we call the V40 figure. V40 is the volume of water above 40 degrees that a cylinder will deliver before it drops below that level. 40 degrees is important, not just because that's roughly the temperature that a shower will run, but also it shows a realistic amount of water that a cylinder will usefully deliver before it runs cold. However, importantly, it's also an official statistic that all manufacturers should be displaying in their literature for direct electric cylinders. It is part of the assessment process for the energy labelling for the cylinder. Now, many manufacturers don't actually show their V40, and frankly, that's because it's not very good. But you can see that where they do, the SX has a very clear advantage of around 20% against all other cylinders. The practical upshot of that, as the installer, is that it means that you can actually install a smaller SX cylinder compared to competing units because of the extra energy which is stored inside it. Sometimes you can go down 2 sizes. You can always go down 1 size. As I say, 20% extra energy compared to the same size cylinder from another manufacturer. Now, this is a winner in every possible way. The smaller Ozo unit will take up less space, it will lose less heat, it will be cheaper to buy, and it'll be cheaper to run. Now, what's not to like about that? On the point of cheaper to run, energy efficiency in hot water cylinders is measured by heat loss. Now, that is either measured by watts or by kilowatt hours per day. I'll come back to that in a little bit with some explanations, but fundamentally, the energy efficiency of a cylinder is defined by the amount of energy it loses through its insulation. The lower the heat loss, the better the cylinder. Now, insulation has come on in leaps and bounds in recent years. Most manufacturers are now using polyurethane foam, or PU foam as we know it. Now, PU foam is very good. It's filled into the cylinder between the cylinder wall and the outer casing. It's good, but it's not the best. The best material is vacuum insulation panels, or VIP as we call it. Now, you will know that you cannot pass either sound or heat through a vacuum. Ozo has been researching vacuum panels for a decade, and we've been fitting them into cylinders for 6 years. This is what we use. Now, this is actually quite a small one. It's sort of a display model, but as you can see, it's flexible, and the way that we use it is that we wrap it around the outside of the pressure vessel of the cylinder and we glue it onto the cylinder, and it gives a dramatic improvement in the energy efficiency of the cylinder. A VIP of 10 millimeters offers the same insulation performance as 60 millimeters of foam insulation. Now, vacuum panels must not be punctured. They must retain their vacuum in order to be effective. And so it's important that they are protected. So the way that we do that is that the cylinders, after they've been wrapped with the vacuum panel, they are infilmed with PU foam. And the PU foam not only protects the vacuum panel, it stabilizes it and keeps it absolutely still, and it also provides an additional level of insulation for the cylinder. When we launched cylinders with vacuum panels, this was actually picked up by the trade press and by the consulting and the specification industry, with the result that we did gain considerable recognition for this innovation, including winning this H&V News, that's the Heating and Ventilating News Award for the most innovative technology in a heating industry product, award that was sponsored by Wolseley Merchants. Well, I'm talking to an audience of engineers and installers, and no doubt you are interested not only in the fitting of the cylinder and how it works, but also hopefully in the maintenance of the product. All the spare parts for this and other products you can see are available from our spares website, which is on the screen at the moment, www.ozo-spares.co.uk. As you might guess, the main parts for the Super S are made for Ozo. The expansion vessels, the multifunction valve, the immersion heaters and the thermostats are all readily available from our parts website and also from Wolseley. Now, you can see that this big brass valve here and certain parts of it, such as the expansion relief valve here and the temperature and pressure relief valve here, they are removable for replacement at any stage that the plumber deems it necessary. However, if you need to replace internal workings of the valve, such as the pressure reducing valve or the blending valve in the current cylinders, it is our recommendation that you actually only replace the working parts of the cylinder, the working parts of the valve, and they can be accessed through ports, which you can see just here. So you've got an Allen key port here for the pressure reducing valve. You've got spanner ports for the mixing valve, and they are easily accessed, and we supply the internal components for that. I'm not going to go through the process of that replacement on this presentation. We'll leave that for another live lounge in the future. But perhaps prior to that, we will produce how-to videos, which we'll post on our website and YouTube channel on how to do maintenance on this valve. Now, from experience, indirect units have connecting points for the heating and the sanitary water services that generally go out to the back and then down the back of the cylinder. Whereas and then the pipes will go in the void between the ground and the first floor. However, for high-rise apartment blocks where the direct cylinder here is commonly fitted, the pipes will come in from the ceiling in that situation, usually because there are concrete floors in these buildings. So that is the Super S. It is innovative beyond belief. Every time we go to a trade show, the plumbers, the gas engineers, they see it, they universally love the idea. It's really, really clever. It is dramatically neater, it's more space efficient, it's faster to install than anything else available. And if you think about it, unvented cylinders, they come in three styles. They've got the standard unit, which has an expansion vessel on the wall. You have the bubble top cylinder or the air gap system. And the third style is the Super Series, which, as far as we're concerned, combines the reliability of the separate expansion vessel, because we know that a bubble top can lose its charge, and the efficiency and the space efficiency, of the bubble top cylinder. By the way, Ozo invented the bubble top unit. This was in the late 1980s, early 1990s, and the idea was borrowed by the company that you think invented it, the one that isn't available at the moment, because when we invented it, rather foolishly, we didn't patent it. You live and learn about these things. So I'll move on from the Super S, which is very clever, and it is actually also patented, this cylinder now. You live and learn, as I say. And I'll talk about the Delta series. Now, the Delta was launched in 2015, and it was the first cylinder that we made that came with vacuum insulation panels. It, at the time, and still is, the only cylinder that is available that is A-rated throughout its range, all the way up to 300 litres. Now, for indirect cylinders, it's not actually that difficult to manufacture a cylinder which is A-rated in a small capacity of, say, 120 or 150 litres. However, the rules are written in such a way that the bigger the cylinder gets up the ladder of sizes, the more difficult it is to achieve that A-rated mark. So much so that the Delta is rated A at 300 litres, and almost all of the competition at 300 litres is a C. That is genuinely true. That is a very big performance gap, and one which will save our customers and your customers money every day of the year that they have that 300 litre A-rated cylinder. And the reason why it's A-rated? Well, you can work it out. It's vacuum panels again, VIP. This was the first unit, as I say, that we made with VIP. The Ozo Delta is, and this is a big claim, but we believe it to be true, the most energy efficient indirect cylinder in the world. End of. We've looked, we've checked, we can't find anything in the industry globally that loses less heat than this product. If you, as an installer, are really focused on the environment, or if you have customers that are really focused on the environment, the Delta is the product that you should be fitting. It's available in a standard indirect from 150 up to 300 litres, as a pre-plumbed cylinder in the same range, a heat pump cylinder from 200 to 300 litres, or as a very large domestic or possibly light commercial unit with 1-inch hot and cold connections and the ability to ramp up the pressure reducing valve up to 5 bar to give really high performance and high flow rates, and that is available from 250 to 380 litres. Although I have to tell you that the 380 litres is actually a B. Sorry about that, we did our very best. So what I'll do now is we're going to play you a 2-minute animation video that we produced to show you the features of the Delta. Since 1970, our Norwegian manufacturing site has used state-of-the-art production techniques and technological advances in design to build cylinders generating hot water in homes all across the globe. Cylinder efficiency is defined by the heat lost through its insulation. Older cylinders are often insulated with a loose jacket, while more modern units have factory-fitted foam insulation, which improves efficiency to some extent. At Ozo, we have revolutionised the design with the development and inclusion of vacuum insulation panels in our Delta range, which absolutely minimises the amount of energy and heat lost through cylinder walls. Our unique panels mean that Delta is the most efficient hot water cylinder available, so where a comparable cylinder only 15 years old loses more than 13 degrees over 24 hours, Delta reduces this to less than 3.5. Think of our vacuum panels as bringing the same level of advancement to cylinder technology as replacing the tea cosy with the thermos flask. The science behind our design generates a unique performance advantage, meaning that Delta will save money on heating bills throughout its lifetime, and with a 25-year guarantee, it offers a smart choice for homes and for the planet. As the only hot water cylinder available with an A-rated energy label throughout its range, it outperforms other units considerably. Delta will generate annual savings for every homeowner of up to £29 against alternative modern cylinders, or up to £78 when compared to older cylinders. The Ozo Delta is the perfect choice for domestic hot water storage. Hi, welcome back. Now, continuing about insulation and heat loss, I'd like to explain further what it actually means, because I genuinely think that many people, most people, even in the industry, don't know what it actually means and how it transfers to a real person in a real house. Every cylinder, by law, has to be labelled with its heat loss, and broadly speaking, the test to establish this is that you heat the cylinder up to 65 degrees Celsius under test conditions which has an ambient temperature or a constant surrounding temperature of 20 degrees Celsius. That is designed to mimic a real-world situation of a hot water cylinder in a normal house, usually in an airing cupboard. Now, this test cylinder is heated by an electrically immersion heater, and as time goes on, it will lose heat out of its insulation. The thermostat will detect this and it will switch the immersion heater on and off to heat the cylinder back up to that point. Now, this test runs for several days, and the amount of electricity that is used to keep the cylinder up to temperature is measured, and it is averaged out for each 24-hour period. Energy consumption is typically measured in kilowatt hours. Now, we in the industry know how much energy costs. And to be honest, right now, the public is probably more aware of how much energy costs now than it was a few months ago. But taking a typical real-world figure round about now in the UK, we're paying about 20 pence per kilowatt hour for electricity and about 5 or 6 pence for gas. If you have a cylinder that loses 1 kilowatt hour of energy per day and was heated by electricity, first of all, it would actually be a pretty good cylinder because most of them lose more than that. But in that situation, that 1 kilowatt hour heat loss per day would cost the householder about 20 pence per day. Or if it was not a gas-fired cylinder, but an indirect cylinder connected to a gas boiler, you would be looking at 5 or 6 pence per day for the indirect unit. Now, that's not actually a massive amount of money compared to the cost of heating water or for consumption, or the cost of heating a house for habitation. But actually, that still doesn't mean a great deal to the consumer, because very often they want to know how quickly or how slowly a cylinder will cool down. And talking about kilowatt hours usually will just confuse them. What they want to know, I think, is how many degrees it will go down in the cylinder per day. Only then can you really understand how good hot water cylinder insulation is. And nobody in the industry talks in these terms, and we really should do, because the results are fantastically impressive. To work this out, you just need some maths and a spreadsheet. Now, my experience of dealing with the general public on this issue is that they often think that if you heat up a hot water cylinder in the morning and then you don't use the hot water, by the time they get home after work in the evening, the cylinder will be either cold or at best tepid. And that's not true at all, nowhere near. It probably was true when cylinder insulation looked a little bit like this. I mean, really? This is what it used to be like. An ill-fitting, loose jacket. But a modern cylinder is so much better. Now, small cylinders lose temperature quicker than larger ones. They have more surface area compared to their volume. At 120 litres, a good cylinder will lose about 5 or so degrees in 24 hours. A bad one, up to 10 degrees. At 300 litres, the Ozo Delta, as you found out a little bit earlier on, loses about 3.5 degrees in 24 hours. A less advanced cylinder, and there's plenty to choose from, will lose about 6 degrees. This is actually where we get the difference between the A, B and C ratings for hot water cylinders. With the level of insulation of a really good cylinder, you could heat the water up on a Monday morning and if you don't use it obviously, it would still be hot enough for a shower a full week later. Now that's impressive. Now we do actually have some questions coming in, but before I answer them I'd like to talk to you a little bit about Ozo Partner and also about the system solution that we can have. Now Partner is a customer reward scheme that allows Ozo customers to earn points for purchasing Ozo products that can then be subsequently exchanged for a wide variety of either industry or consumer related products. We launched Partner 2 years ago, just at the wrong time, only a few weeks before the arrival of coronavirus, but now we really are pushing forward with it and we're trying to sign up as many gas engineers as plumbers as we can. It's very simple. There's a QR code on the screen that will remain there for the next 30 seconds or so. So you can point your phone at the screen and it will take you to the website, or alternatively, if you're watching this broadcast from a phone, if you just go to osopartner.co.uk and scroll down, you can apply for membership. Fill in the form, click submit, and you will get an email back from Partner straight away where we ask you to click on the link and hey presto, you're a member of Ozo Partner and you can start earning points to be spent on almost anything, from kitchen utensils to a holiday in the sun. Now I mentioned at the top that Ozo is a systems solution when it comes to hot water. The UK water heating landscape has shifted this century in the last 20 years from vented cylinders, which are fed by roof tanks, with rubbish pressure and rubbish flow rate, to much better engineered, high pressure, high quality, unvented cylinders that are fed directly from the mains. They're much better. Power showers without the need of pumps, no moving parts, silent in operation, but what is the thing that can make them not work? Poor water pressure, or to be precise, poor water flow rate, because in reality, actually, the water pressure, the static water pressure, is normally pretty good. But if you or your customer has a large house with multiple bathrooms to supply, the flow rate coming into the house might not be good enough for this task. In that situation, you need an accumulator system. The Ozo SuperStream is a product that we've been supplying for over 20 years, and it boosts the flow rate by storing cold water in a giant expansion vessel and using it to support the incoming mains supply. Now the image on screen is a single large accumulator, but they can actually be banked together for multiple commercial installations like sports centres, hotels, anywhere that really needs super high flow rates. It really is a fantastic system. It can boost water up to 80 litres per minute using no pumps and making no noise. It's just simple hydrodynamics. SuperStream is a system solution. You get a composite construction accumulator vessel that is lighter and more corrosion resistant than a steel vessel, and you get an upstream kit that provides the link between the incoming water main and the cylinder which is further downstream, and the cold water services also that sit downstream of the SuperStream cylinder. Now you can see that the upstream valve contains a line strainer, a pressure reducing valve, a double check valve, adjustable pressure reducing valve and a system pressure gauge, so that we're actually displaying full mains pressure and the regulated mains pressure. Do not be tempted just to go out and buy an accumulator or buy a large expansion vessel and expect it to work in that situation, because you really are asking for trouble. The system has to have valve protection, or the likelihood is that the vessel will burst with very messy and very expensive consequences. Now, we are experts in this. As I say, we've been doing this system for 20 years. We know what we're talking about. Come to us, we will guide you through it. Well, that's what I have to talk about the Ozo cylinders. We do actually have some questions which have been submitted, so I'll just run through some of those. The first one is there a secondary return on the Ozo cylinders? Well, the answer is yes. I'll show it to you on the Super SC here. On the back of the multifunction valve, in fact, I'll turn it around slightly so you can see it from that direction. So you're now looking at the cylinder from the rear. This connection here is a dedicated secondary return facility. Just to remind you, you've got cold water in there, pressure reducing valve, balanced cold water out of there, hot water out of there, secondary return point here, primary flow, primary return expansion vessels. So yes, is the rather long answer to is there a secondary return. Another question is, do we make anything bigger than 300 litres? And the answer to that is also yes. We have a commercial range that starts at 300 litres in both direct and indirect. The difference between the commercial direct at 300 and the commercial and the domestic direct at 300 is basically the amount of immersion heaters that we have. So we have systems that can provide 30 kilowatts of electrical power in a 300 litre and a 400 litre, 600 litre, 1000 litre and beyond vessel. So we make cylinders in the multiples of thousands of litres. So we have the full range from the smallest domestic at 120 up to, well, if you come to us and you want an 8,000 litre vessel, we can actually make it for you. So yes is the answer, we do make large commercial cylinders. One other question that we've had. Do we make a horizontal cylinder? No is the answer to that, and I'll tell you the reason why. It's because they're rubbish, basically. I really don't like the idea. We've been asked God knows how many times, do you make a horizontal cylinder? I'll tell you the reason why. Heat rises. When you've got a cylinder which is laid on its side, essentially, it's not very tall and it's very wide. And when you put cold water into the bottom of an already hot cylinder, it will try and mix up. And the less high, the shorter the cylinder it is, the more mixing that you're going to get. But we do have a solution. What we recommend very strongly is our smallest domestic cylinder, which is 120 litres and frankly is about that high. If you put two of those together, so it comes up to about this point on me or on this cylinder, if you put two of those together side by side and bank them, you will then get roughly 250 litres of stored hot water. It will work brilliantly and it will work far better than a horizontal cylinder, and it will take up about the same amount of space. That's what we suggest. It's a far higher performing system. So thank you very much for your attention. I really do appreciate you dialing in and watching this broadcast. I hope that we will do another Gas App Live Lounge at some point in the future. Thank you very much. I'll see you again. Cheers. Bye-bye.